Right. Assalamualaikum and good afternoon. How are you? Right. I hope everybody is good. Yeah, in good condition. Right. Okay. Now, this is our post lab. Yeah, the first hour is for post lab for experiment two. Remember what we did last week? We did some kind of titration, and we prepared a standard solution of oxalic acid. And in part B, we need to determine the concentration of NaOH, and finally, we need to determine the concentration of hydrochloric acid. Right. Okay, now to the calculation. Okay, this is some sort of readings that you might have got from the experiment last week. Okay, look at the gross reading here. These are just examples. Yeah, of course, this one differs to what you have, yeah, in your report. Now, final reading is 26.7, and then initial reading is 1.2. Therefore, how do you get the volume of NaOH? You just minus the 2. Yeah, we get 25.50. But normally, this is for gross reading. Gross means rough, yeah, which means it is just an estimation. Yeah, estimate volume of what the actual volume of titrant should be. Now, so 25.5, when you add in this much of volume, you might have exceeded the actual endpoint. Maybe the color was very purple, yeah, last week, not the light pink that we want. Therefore, we know that for the actual titration, titration 1, titration 2, titration 3, we need less than this. Yeah, we need less than 25.5. Therefore, yeah, maybe the first 23 milliliters you can go very fast, and after that, you can go very slowly. And don't forget to rinse the inner wall of the conical flask as well as the burette tip, yeah, every now and then. Now, okay, look at my readings. Yeah, I have initial reading 24.55. Look at the final number, it is 5. This one, the final number is 0. Okay, none other than 0 and 5. Yeah, remember, if it is exactly at the line, then you record it as 0. If it is in between the two scales, yeah, the two lines of the scale, then you record it as 5. No 4, no 2, no 7 whatsoever, only 0 and 5. Now, must be recorded to two decimal places. Yeah? If not, marks will be subtracted. Okay. Then we go to the mass of oxalic acid. Okay, my mass today is 3.0005 gram. Yours, okay, maybe 2.999, up to you, yeah. But remember, the reading must be recorded to also four decimal places. Every single number appeared on the scale must be recorded. Okay, how do you calculate the number of mole of hydrated oxalic acid? You take the mass divided by the molar mass, which is 126 gram per mole, and maybe you will get something like 0.03238, something like that. Yeah. Um, this is not the actual number, just example. Then, how do you calculate the molarity of oxalic acid? Remember, all this we dissolve in water and put every single solute in the volumetric flask and make it up until 250 ml. Therefore, yeah, how do we calculate the molarity? Molarity is just N of solute in mole over the volume of solution in liter. That means it is just the number of mole over 0.25, which is the volume of solution. And in this case, maybe you will get around 0.095, blah, blah, 9514 maybe, yeah, molar. Yeah, remember, this is just example. Right. So knowing the molarity, now we go to the calculation of the titration. Okay, just now was just the preparation of oxalic acid, the standard solution. Now, We took, you took 25 ml of the oxalic acid. Did you do anything to it? No, right? That means the molarity must be the same. The molarity is, in this case, maybe 0.09514 molar. The volume was 25 ml, and you titrate it with NaOH. Okay, what do you get from the 4 NaOH? You don't know the molarity, but you know the volume. Right, the volume just now. Let's go back to the volume of NaOH. When you calculate the average volume, you just consider reading number 1, yeah, this one here, number 2 and number 3. That means, yeah, for average volume, gross volume is not taken into consideration. You don't include this one. You just include 25.25 plus 25.50 plus 24.95 over 3. Yeah? Volume 1 plus volume 2 plus volume 3. And this is the value of volume here. We know that. Of course, when NaOH reacts with oxalic acid, yeah, we need to have the reaction equation. And why is this important? Because we want to know the mole ratio. When we balance this equation, we'll get the mole ratio to be 1 to 2. So 1 mole of H2C2O4 reacts with 2 moles of NaOH. And remember, how do we calculate mole? We know the volume, 25 ml, and we know the molarity. So N is just M times V. Yeah, we have 0.025 liter. Yeah, that is the volume times the molarity. And that will give you the number of mole. Yeah, sorry, of H2C2O4, and you can calculate the number of mole of NaOH. You can solve for X and get the number of mole of NaOH. And remember, you want to calculate the molarity. N of NaOH equals to M times V. N is the value here. V is the average volume of NaOH, and you can solve for M. Done. Or if you don't like this method, you can also use the formula, the mole ratio that you have seen from school, I think, in which you have MAVA, or this is or, over MBVB. Okay, A means acid. So the mole ratio of acid is 1 in this case. And the mole ratio of base is 2. Yeah, 2. And you can substitute. You know the molarity of acid. You know the molarity of, volume of acid as well. And you know the volume of base. And you can solve for the molarity. Yeah, this is quite straightforward. Yeah, shorter than the one before, but same concept. Either one is fine. And finally, for the discussion, as usual, you need to compare the experimental value with the theoretical value. And in this case, the theoretical value for NaOH is 0.2 molar. And again, in your discussion, you have to state the errors. Okay, I believe most of you, all of you maybe obtain purple color instead of pale pink color. So I think that is the major error. Okay, how do you explain that? Okay, the endpoint should be pale pink color, right? So in this case, you say that you obtained inaccurate endpoint due to excess addition of titration. The titration is NaOH. So how do you overcome that problem? Titrate very carefully toward the endpoint or slowly, yeah, up to you. And how do we prevent that from happening again? The precautionary step, you have to rinse the inner wall of the conical flask and the tip of burette to avoid exceeding the endpoint. Yeah, this is plus to the titration that must be done very slowly towards the endpoint. So that is one. You have to come up with another two. Think of what you did last week and explain. And as usual, conclusion, just answer the objectives. Must be very simple and very brief. How about the answers to the exercises? Okay, include that in the discussion. Only the answers. Yeah, after you have finished writing these two, yeah, number one and number two, you can include the answers to the exercises. All right, I think you can proceed with your post lab, complete your report, and submit. Yeah, I will provide a link in the Google Classroom and also Microsoft Teams. Right, thank you very much. All the best.